NaxToPy, understanding the result structure. Welcome to NaxToPy. In this video, you will learn how to access model results, understand load case structures, and use NaxToPy's tools for detailed analysis. We will be using a Jupyter notebook, which you can download along with all other materials from the link in the video description. To begin, we will explore how to access load cases, results, increments, and how to combine them for analysis. The load_model function loads both the mesh and result structures from your file. The model contains a list of load cases, each containing increments and a results dictionary organized by components and sections. Accessing load cases. There are three ways to access load cases. 1. Using the load cases property. This lists all load cases in the model. 2. Using the get_load_case method. This allows you to retrieve a specific load case by its ID. 3. Using the get_load_case method, this allows you to retrieve a specific load case by its name. Displacements. Understanding results dictionary. Every N2P load case includes a results dictionary, where each result is an instance of the N2P result class. Accessing results. You can access the entire dictionary of results for a specific load case using a_loads results. To focus on a specific result type, such as displacements, use the get_result method. Practical example. Retrieve displacement results, use get_result, displacements, to access the displacement data for a load case. Increments. Understanding increments. This object contains a list of increments, which represent different frames or time steps in your analysis. Each increment is an instance of the N2P increment class. Accessing increments. You can retrieve increments in several ways. 1. By index, use get_increments, index, to access an increment by its index. 2. By time value, use get_increments, t1 equals 0.1, to access increments by time value. 3. Complete list. Use the increments property to get all increments for a load case. Active increment. The active increment property determines which increment is used when retrieving results. You can modify this by setting it directly or using the set_increment method. Practical example. Set active increment. Use set_increment, 1, to set the active increment to index 1. After setting the increment, you can immediately call subsequent methods like get_result, displacements, on the same object, making the process more efficient. Results and components. Accessing components and sections. Components dictionary. Each N2P result object contains a dictionary of components. You can access this using the components property. Retrieve specific component. Use the get_component method to retrieve a specific component, such as displacement.get_component, x, to access displacement along the x-axis. Sections. Each N2P component can have associated sections. You can access them using the sections property, which helps you retrieve more detailed result data. For displacements, it doesn't make sense to talk about sections because they are measured by the node's movements. That's why we are going to use stresses to check the sections we can find inside. In this case, we are going to see that we have sections Z1 and Z2. Result arrays. Methods to retrieve data. Use get_result_list to get data as a Python list or get_result_nd array for a number p-wind array, which is more efficient for numerical operations. Now we can see the results of displacements in coordinate x. Importing load cases. When subcases are saved in separate files, you can import them into NaxToPy efficiently. Import results from files. Use the import_results_from_files method from the N2P model content class to combine mesh and results from different files into one cohesive model. Create derived load cases. Combining load cases. Creating derived load cases. Derived load cases allow you to combine existing load cases. Use the new_derived_load case method to create a new load case by specifying a formula for scaling and combining load cases. In this example, a derived load case derived LC1 scales an existing load case, LC17500, by a factor of 1.5. Accessing derived load cases. You can use the get_load_case method to retrieve both standard and derived load cases. Step 1. Create a new envelope load case. Use model.new_envelope_load case to create a load case. Name it. Set the formula. This combines results from LC17500 at FR1 and LC1 at FR0. Step 2. Retrieve all load cases. Call model.get_load_case to fetch all defined load cases. Save the result in load cases. Step 3. Display the load cases. Print load cases to confirm the new envelope load case is listed. Verify its name, formula, and associated results. Create a free body. Creating a free body. The create_free_body function allows you to create a free body in the model, calculating forces and moments acting on specified nodes or surfaces. The method returns an NaxToPy free body object that contains the resultants of forces and moments. Conclusion. With NaxToPy, you can efficiently manage and analyze load cases, increments, results, and derived cases. The flexibility provided by these methods, whether accessing data by index, name, or formula, gives you powerful tools for detailed analysis. Additionally, creating free bodies helps to understand the overall behavior of structures under various conditions. We hope this video has been helpful. See you in the next tutorial.